Okay guys, this is day 8, part 2. So we left off on question 5. Find a picture of Deinonychus and 3 of its relatives. What feature do the birds all share that Deinonychus does not? Okay, so here it is right here. So we're going to click on that. Or maybe, no, we're going to go to the next page. Okay, all of these animals share features inherited from a common ancestor. They are a type of dinosaur called theropods. Just click on the word theropods to see what features early theropods inherited in their ancestors. So theropods had carnivorous teeth, long tail, 3 toes, and 3 fingers. Okay, Archaeopteryx, the crane, and the eagle have some features that are different from the Deinonychus. This allows us to put them in separate groups called birds. Click on birds to see how the features are changed. So they have reduced teeth, longer arms, shorter tail, and flight feathers. So the question was, what feature do the birds share that Deinonychus doesn't? So they have 3 toes, longer arms, shorter tail, flight feathers. So they have feathers and it does not. And long, shorter tail and a short tail. I mean, you could really do any of these. Not carnivorous teeth, short or longer arms, shorter tail, flight feathers. So that's number 5, if you need to pause it to put in your answer. During this tour, you will learn about cladograms. When you reach this point, complete the sentence. A cladogram is a diagram that shows... All right, so let's move on. The crane and bald eagle belong to an even more exclusive group called Neuronites, a Latin word meaning modern birds. All living birds should share certain features not found. Here we go. I didn't go far enough. Sometimes that happens. They have no teeth. Their arms, so this is the answer to number 5. No teeth, arms are longer than legs, very short tail, and specialized feathers. So this compared to this. So this is the answer to, so they have no teeth and, or these animals have teeth and these have feathers. All right, so here is a cladogram to show evolutionary relationships. The branching diagram beneath the picture is a cladogram. Like the boxes, it shows how each group of animals is related to the others. So each branch of the cladogram represents a group of organisms that share special characteristics inherited from a common ancestor. Cladograms can be used to illustrate evolutionary relationships and patterns of divergence. So here we go. Cladograms is a diagram that shows evolutionary relationships. So, sorry, one hand typing. Okay, find the bar graph that shows the difference in beak size among 3 species of Galapagos finches. Name the species of finch that has a beak that can be longer than 15 millimeters. All right, so let's go to the next one. So a cladogram is like a tree, a family tree. Notice where the lines intersect. Each of these intersections represent a shared common ancestor. Click on the common ancestor represented by blue dot to see its descendants. Now click on the common ancestors represented by the green and red dots. So like if I blue, all of these are related. But if we get in a little bit closer, this one is less related. So the closer they are together, the more related they are. Or they share more commonalities. So to which animal are the crane and eagle most closely related to? Well, obviously this one, because it's closer to them. As you get further down the family tree, the less related you are. All right, scientists examine several lines of evidence to determine evolutionary relationships among organisms. We have just examined how groups of organisms are related because they are inherited certain physical features. Scientists can also use behavior, embryology, and DNA. But how do organisms and their features evolve? Variation is essential for evolution. All populations of organisms have individual differences. These kittens look a lot alike. They have the same kind of fur, except for one, but the same coloring, stripes, and so on. But look closely. Even though they are all from the same litter, there are differences and variations among them. There are also variations that you can't see. These include personality, resistance to disease, and many others. Without variation, evolution cannot happen. Organisms may have variation that help them survive. If so, they will reproduce and pass those variations on to their offspring. This can lead to the formation of a new species. So these are the Galapagos Islands. This is a very popular study. One example is the Gopikas Finches. Charles Darwin visited the Galapagos Islands in 1835. He was surprised by the number of different finch species that existed in such a small area. Each group of finches were adapted to different regions, sources of food, and lifestyles. The bar graph shows the difference in beak sizes among the three different Galapagos finches. Look at the graph. Which statement is true? There's no difference in beak size among the species. Beak size is directly related to the food the finches eat, and Geospiza scandens have the shortest beak. All right, so here we have Geospiza fulginosa, small seeds and nectar. This is their beak length in millimeters. So this guy, his beak doesn't get much bigger than 9.5 millimeters. But most of them are around this, just a little over 8, because this is the number of individuals of this species. So like some, like less than 10%. This would be less than 10%. So less than 10% have like 6, less than 10% have 7, or this would like 5, 6, 7. Over 20% have 7, over about almost 30% have 8. Then it drops down for, I don't know exactly, this would be 8.5. So I guess it varies, sorry. I'm reading the graph as I go through. All right, then the middle guy, he eats small and medium-sized seeds. So his beak is a little bit bigger. And then we have this overlap of green. I'm not sure what that is. And then this animal eats out of a cactus. So that makes a little bit more sense, right? That their beaks would be a little bit longer because they need to get inside of a cactus. However, less of the species it's more spread out. So what do you think is true about this graph? There's no difference in beak size. Beak size is directly related to the food. Or Scandinus have the shortest beaks. Well, they obviously don't have the shortest beaks. That would be this blue. They have the longest beaks. So beak size is directly related to food. Sorry, I hit my phone. Oh, we had a question on that. Name the species of finch that has a beak that can reach longer. So that was the one we just, Geospiza scandens. I'm going to put scandens. Oh, my daughters. Okay. Okay, find the page showing 3 graphs side by side. The graph on the right shows an increase in the finch's body and bill size. Why did that happen? Okay, I'm going to click this again. All right, variation affects how an organism can live and exploit its environment. Remember, the idea about variation within a population, this graph shows that there is quite a range of beak size within this group of finches. Let's see why that variation may be important. Think about what would happen if the environment changed and only plants with larger, harder seeds survived. How do you think that might affect population of Geospiza fortis finches? Click on the best answer. The population would stay the same. Finches with smaller bills would thrive. Finches with larger bills would thrive. So they have larger, harder seeds. So they would need a bigger, stronger beak. So the ones with the larger beak would thrive. Over time, natural selection causes changes in features. In 1976, one of the Galapagos Islands was struck by a drought, killing many of the small, soft plants such as grasses. There was an increase in the plants with larger, harder seeds as they survived the drought better. The change in vegetation caused the population of fortis finches to drop from 1,400 individuals to only 200, and most of those survived tended to have a particular body and beak size. What finch body and beak size was favored as a result of the change in the diet? So, finch beak and body size. So, which population grew? Obviously, blue went down. This stayed the same. But look at this one. The number of finches, the beak and body size grew. Which beak and body size was favored? Yeah, so which beak and body size got more common? So it'd be this one. The finch with the larger bodies and larger bills survived better because they were able to eat the larger seeds. With more food available, they had a better chance of surviving and breeding. Over time, the new generations, Geospiza fortis, became larger and had larger bills. Scientists continue to see bill size and shape change with finch populations when the vegetation changes. That's evolution in action. So we had a question on these three. Find the page. The graph on the right shows an increase in finch's body and bill size. Why did this happen? So why, looking back, why did these thrive? What happened? There was a drought that killed the small seeds. Therefore, the animals with small bills decreased, but animals that could reach and eat larger, harder seeds, because this was an increase, survived the drought. So that's what you need to put. There was a drought killing small seeds, so animals that could eat larger seeds survived the drought. Put that there. Press pause to answer. Okay, natural selection is not the only mechanism of evolution. Anything that changes the genetic makeup of a population can influence evolution. Examples include genetic mutation and geographic isolation. Nevertheless, over 150 years after Charles Darwin published his theory of natural selection, it is still considered one of the prime movers of evolutionary change. What's our next question? What is a quiga and why can't we have one for a pet? Paleontologists estimated all of the species that have ever existed, 99.9% are now extinct. Click on all four of these extinct organisms to learn a bit about them. So this is a trilobite. You guys can read about them. This is an ammonite. A lambeosaurus. And here's a quiga. Although extinction is a natural process, human activity has a rapidly increasing the rate of extinction. Here is just a few organisms that have been affected. The quiga was a close relative of zebras and like zebras, it lived in Africa. But the 1870s, many of them had killed off by humans for their hides. The last quigas died in the zoos in 1880s. Okay, so what is a quiga and why can't we have one as a pet? Well, they're not living anymore, but it's like a zebra, and they're extinct because humans were killing them for their hide, which means they're like fur. Okay, super bonus. What is a nasal passage and how might Lampeosaurus have used them? So that was this guy. Lampeosaurus was a crest hadrosaur, or a duck-billed dinosaur. Such dinosaurs were typical of the late Cretaceous period from 100 to 65 million years ago. The unusual crest of the head is hollow and contains a long nasal passage. Lambeosaurus and other crested hadrosaurs may have used their crest to create loud noises. So what was that long nasal passage for? Creating loud noises. All right, we are finished. Oh wait, I think. Through all living things are related through a common ancestor, life continues to change, resulting in biodiversity we see today. That is the end. You should have this done, all your answers. Now all you have to do really is you can share it with me. Click share at the top. Put a Giza King. And done. Let's see. If I put, you can send me a message too. Hey, Giza King. You can say, hi, how are you? What you up to? Thanks for the help. Okay. And click done and it'll send it to me. And then you're done. Assignment 8 complete. Or, I'm sorry, I made this video for every teacher. So if you are Janestra's or Mr. Utgard's or Miss Jepson's student, you can write their name in here and send it to them. Don't send me your stuff if you're not my student. I can't grade it. All right. Bye, guys.